So now we're going to talk about the SR latch, and this is the most basic memory element you could have. It's really exciting to study this part because it is the basis of every storing element you find on the market. Now, I know there is different topologies for storing all around the memory technology, but the SR latch is still one of the most used topologies around here. So let us get started and let us see bit by bit how can we design this SR latch, and you'll see how great it is. So let us get started. What does it even mean to store something? Well, now assume that I have a black box right here, and all I care about is functionality. I want to store a 0 if I press this button, or I want to store a 1 if I press this button. And when I release my hand and I don't press any of the button, I want to see here at the output whatever I stored. So if I press 1 right here and I release my hand, I want to see 1 at the output right here without even having to keep pressing this 1. If I press 0 again, what I want is here this 1 to turn to 0 and stay there permanently. Well, let's see how we can do that. So this is how we store a 0. If we press, we're going to store a 1. Now, I'm going to call this operation of storing a 0 a reset, because whenever you hear the term reset, it means you're just storing a 0 at a storing element. Or whenever you're saying we are resetting the device, what you're doing is you're resetting, or you are writing zeros to some parts of the memory in order to start at the initial state one more time. Now I'm gonna call storing 1 the set operation, right? So if I store a 1, I am setting this operation. So the main difference here is that all I need to do, because this is a sequential logic, I just need to press this input for a very short amount of time, and I don't have to keep pressing it in order to see something at the output. But for combinational logic, I don't have a storing element. I mean, if I have an AND gate right here, I need to keep pressing both of these inputs, and I need to give them both the one logic in order to keep seeing one logic at the output. If I release any of them and one of the input is not one anymore, well, I'll be having a 0. So that's the main difference between combinational and sequential. Now, let's see how we can design it. This is what an SR latch looks like. It could be designed with NAND and it could be designed with NOR gate. But let's start with the NOR gate and see how we can design it with the NOR gate. Take a look at our truth table. We have S and we have R, set and reset. Then we have Q for output and Q hat for not output. So if I have 1 here, I will be having a 0 here. If I have 1 here, I will be having a 0 here. So they are the opposite of each other. Now, this is the logic. If my S and my R are both 0, I'm gonna retain whatever value I have on Q. So if I have a 1 right here, and both of these are 0, the one here will stay as it is. Now if I have a 0 at the Q, and both of these are 0, this 0 on Q will stay as it is. So 0, 0 will retain the last value I have on Q. Okay? Next. Now, if my S is 0 and R is 1, it means I am doing a reset, because well, set is 0 and we are pressing the reset. So the Q right here is going to be 0 because we are resetting. So if I had a 1 here and I press R, this one will turn to 0. If I have a 0 here and I press R, this Q will stay at 0, as long as the S is also 0. Now the set operation is the opposite of reset. The S need to be 1 and the R need to be 0. In this case, if I press S, I will see 1 here at Q. And let's say I had a 0 right here, I press S, it will turn to 1. If I already have a 1 and I press S, the 1 here will stay as it is. So the 1, 0 here is going to set the Q. Now, assume that I have pressed set and reset at the same time. Well, this operation is not allowed because we cannot be setting and resetting at the same time, because think about it. You are setting here to be 1, but you are pressing this R in order to reset it and to turn it to 0. So you're going to enter a state where it is debouncing between 1 and 0, 1 and 0 infinitely. So we need some mechanism, which we will see later, in order to prevent this S and R being set at the same time or being 1 at the same time. Now let us follow how this topology is working step by step.